Hello everyone. Welcome to this lecture of regression analysis and its types. Regression is one of the most important statistical and machine learning technique. It is used for understanding relationship between variables and making predictions. It plays a crucial role in various domains including business analytics, finance, healthcare, engineering, and artificial intelligence. So, in this presentation, we will explore the concept of regression, understand why it is important, and discuss the major types of regression techniques along with its applications. By the end of this lecture, you will have a clear understanding of how regression works and how different regression models are used to solve real world problems. So let us begin by looking at the topics that will be covered in this lecture. Firstly, we will understand what regression is and why it is important. Then we will study various regression techniques including linear regression, multiple linear regression, polynomial regression, logistic regression, and regularized regression models such as ridge, lasso, and elastic net. Finally, we will compare these techniques, discuss their applications, and summarize the key concepts learned throughout the lecture. So, regression is a statistical method, as I told you before. It is used to analyze the relationship between a dependent variable and one or more independent variables. The primary objective of regression is to predict the value of a target variable based on the value of predictor variable. For example, suppose we want to predict a student's examination score based on the number of hours they study. In this case, the examination score is the dependent variable while study hours serve as independent variables. So regression helps us identify patterns in data and develop mathematical models that can be used for prediction and decision making. So because of its ability to uncover meaningful relationships, regression has become a fundamental tool in data analysis and machine learning. So, why regression matters? Now, let us understand why regression is so important. Organizations and researchers use regression to make informed decisions based on data rather than assumptions. So, regression can help predict future sales, estimate market trends, understand customer behavior, forecast stock prices, assess risk, and evaluate healthcare outcomes. One of its biggest advantages is that it enables data driven decision making instead of relying on intuition uh, alone. Organizations can use statistical evidence to support this strategy. So, in today's data rich world, regression serves as a fundamental for predictive analysis and business intelligence systems. Next comes linear regression. So, it is the simplest and most widely used form of regression analysis. It models the relationship between a dependent variable and a single independent variable using a straight line. So the mathematical equation for linear regression is y is equal to a plus bx. Here y represents the dependent variable, x represents the independent variable, a is the intercept and b is the slope of the regression line. The slope here indicates how much the dependent variable changes when the independent variable changes by 1 unit. For example, we can use linear regression to predict a student's marks based on study hours. So the major advantage of linear regression includes simplicity, ease of interpretation, and computational intelligence. Next comes multiple linear regression. So while linear regression uses only one independent variable, many real-world problems involves multiple factors. To address such concerns or such situations, we use multiple linear regression. So its equation can be represented as like y equals a plus b1 x1 plus b2 x2 plus bn xn. So in this model, several independent variables contributing to predicting the dependent variable. For example, house prices depend on multiple factors such as area, location, number of bedrooms, age of property, and nearby facilities. So, by considering multiple predictors simultaneously, multiple regression generally provides more accurate prediction than simple linear regression. So, it is extensively used in economics, finance, market analytics, and social science research. Next comes polynomial regression. So sometimes the relationship between variables is not clear. In such cases, a straight line cannot accurately represent the data. So polynomial regression is designed to model these nonlinear relationships. The equation includes higher order terms such as x squared, x cubed, and so on. So as a result, the regression curve can bend and adapt to complex patterns in the data. For example, it is used for growth forecasting, scientific modeling, and such similar kind of applications. So, um, however, one should be cautious when selecting the polynomial degree. A very high degree may lead to overfitting, where the model performs well on training data but poorly on unseen data. Here comes logistic regression. So, despite its name, logistic regression is primarily used for classification rather than prediction of continuous values. So, instead of predicting a numerical output, logistic regression estimates the probability of an event occurring. The output typically ranges between 0 and 1 and is often converted into categories such as yes or no, true or false, positive or negative. So, for example, logistic regression can be used to determine whether a patient has the disease, whether an email is spam, or whether a customer is likely to leave a company. So, because of its simplicity, interpretability, and effectiveness, logistic regression remains one of the most popular classification algorithm in machine learning. So here comes regularized regression techniques. So a data set becomes larger and more complex. Traditional regression models like linear or logistic may suffer from overfitting. So overfitting occurs when a model learns the training data too closely and fails to generalize a new data. So to overcome this issue, regularization techniques are employed. The first technique is ridge regression, which introduces an L2 penalty term and reduces the magnitude of coefficients. The second technique is lasso regression, which uses an L1 penalty. In addition to reducing coefficients, it can eliminate less important variables, effectively performing feature selection. So the third regularized regression technique is elastic net regression, which combines the strength of both ridge and lasso methods. So these regularization techniques are widely used in machine learning applications where datasets contain a large number of features. So let us conclude by reviewing the key points discussed in this session. Regression is a powerful statistical technique used to model relationship and make predictions. Different regression methods are designed for different situations. Linear regression is suitable for simple linear relationships. Multiple regression handles multiple predictor variables. Polynomial regression is used for classification tasks. Ridge, lasso, and elastic net regression helps improve model performance and reduce overfitting. So these techniques have extensive application in business analytics, healthcare, finance, engineering, and artificial intelligence. So as data continues to drive decision making across industries, understanding regression becomes increasingly important for researchers, analysts, and data scientists. So, thank you for your attention. I hope this lecture has provided you with a comprehensive understanding of regression and its various types. Thank you. Have a great day.